Okay, hopefully you can see my screen. Okay, in the last lecture, we introduced the almost all the steps about the super pale mix design, including the selections of the materials, the design of the aggregate structures, the selections of the binder contents, and the last step, the moisture sensitivity analysis of the sample. And we stopped at the indirect tensile strength for the specimen. Actually, we have some preliminary process about the specimen, and after that, we will do the indirect tensile strength estimation, which is determined by this equation. And we will try to understand the or actually estimate the average dry tensile strength for the 3 samples. We do the test, apply the tension load to the specimen until it failed. With that, we're going to estimate the tensile strength. And as we have 3 samples, we can find out the average value. For the dry sample, we have the average dry tensile strength. For the 3 wet sample, we will get the average wet tensile strength. So with that, we will have the ratios between the wet and the dry samples. Usually the tensile strength from the wet samples will be smaller than the dry samples. But we want to control the specimen, control the design of the super pale mixed design for the sample to make sure that the tensile strength ratio, which would be the ratio between wet and dry strengths, to be higher than 80%. And this is the equation that we calculate. For example, for one typical sample, if you find out the wet strength is around 721 kilopascal, and the other one is 872 kilopascal for the dry strength, then you will obviously observe the tensile strength ratio as 82.6%, which is higher than 80%. If this one is satisfied, we say that this design is appropriate as it's already exceeds the minimum requirement about the TSR. So this would be the last step from the moisture contents. So after you finish everything, you find out that all the criteria are satisfied in the selections of the asphalt binder in the moisture sensitivity analysis. Then we can conclude the one that we select would be the aggregate that we select, the asphalt binder we select, can be used for the real world pavement design. This is actually comes from the super pale mix design. So for example, for all the examples that we analyzed previously, we can conclude that for the aggregate, we need to choose 10% number 1 stone, 15% of the 12.5 millimeter chips, 30% of 9.5 millimeter chips, 31% of the manufactured sand, and 14% of the screen sand. So this would be the aggregates that we're going to select and going to mix together. And by combining them together, you can find out the gradations of the aggregate that we blended for the super pale mix design. So you can find out the distributions and the different size of the particles at 25 millimeters, which is around 100%. And for the portion which less than 0.075 millimeters, that will be less than 3.5%. So this is the candidate aggregate gradation that we can use for the design. And we also need to select the amount of the asphalt binders. So for the asphalt contents, we based on the analysis in the third step about the selections of the asphalt binder, we can get the value, the percentage as 4.7%. And also we will choose the materials. In the first step, we choose the materials of the asphalt binder based on the climate conditions and say that we have the value around a performance grade of 58 minus 34 for the asphalt binder. So this is the whole process. So after you conduct all the experiments, all these 4 steps, eventually you will have the working sheet, which will show you the how much of the of each type of the materials we're going to use for the aggregates, what kind of asphalt binder we're going to use. And then Then we choose this amount for the real world pavement construction and mix them together for the design. So this is for the general super paved mix design procedure. We also have some specific requirements or specific protocols in Ontario. The first thing is like in Ontario, we actually categorize the traffic into 5 levels. That varies from A to E. When the 20-year designed ESAL, the equivalent single axle load, which is related to the traffic volumes and or especially truck volumes on the road. We will have more introductions about how we going to analyze the traffic and how we're going to define the ESAL in the future slides. But for now, let's just know that this will represent the traffic volume. If the ESAL is less than 0.3 million, then that will be the light traffic, category 1. It will be in the low volume roads. It could be the parking lot, the driveways, or some residential roads with a very small number of the traffic there. And the second degree, second level would be B. That means that the traffic is between 0.3 and 3 millions for the 20-year design life. This will usually apply for the minor collector roads. And the level C represents the flow of 3 to 10 millions, which will be the major collectors and the minor arterial roads. And category D will represent the flow between 10 and 30 millions, and that will be the major arterial roads and some transit routes. The last one, which will have the very heavy volumes, the traffic will be more than 30 million for the design life. This will be the freeways, the large freeways, the major arterial roads with very heavy traffic, truck traffic, and also some roads which were designed for the trucks and the bus, or some stopping area, the wait station, and so on. So this is the category of the traffic in Ontario. And the next thing is about the super paved mix design. The criteria is actually based on the traffic conditions. For the 5 different categories, we will have different requirements about the sand equivalent. We have the minimum value of the sand equivalency. For categories A, they should be at least higher than 40%. We also have the uncompacted void content requirement. The minimum value should be defined by these two columns, and this one is determined by the depth of the materials applied. If the depth is less than 100 millimeters, then we're going to use the column on the left. If the depth is higher than 100 millimeters, then we're going to use the column on the right. We also have the flat and elongated particle percentage requirement. The maximum value should all be 10%. So all this percentage should be less than 10. And also we have the fracture particles in the coarse aggregates, and this one defines the minimum percentage. We have the of course this one is also related to the depth of the aggregates applied. If it's less than 100 millimeters, we're going to use the column on the left. If it's higher than 100 millimeters, then we're going to use the materials on the right. And there will be 2 values. The one on the left shows the percentage for more than one face, and the one on the right shows the percentage for more than 2 faces. So this is about the selections of the materials for the aggregates. And the other things about the selections of the asphalt binders. In Ontario, we have very varying traffic climate conditions. Ontario is pretty large. The northern Ontario will have very different weathers compared to the southern Ontario. Based on the protocols in Ontario, we will actually categorize Ontario into 3 zones. You can find out the map here shows the regions of each zone. So in each zone, we will have definition specification about the performance grade of the asphalt binders, depending on whether it's in a new hot mixed asphalt binder or it would be in the reclaimed asphalt binder. If it's new, or if it is an asphalt binder with less than 20% of the reclaimed asphalt binder, then we should use the first row. If it has more than 20% of the reclaimed asphalt binder, then we're gonna use the second row. Basically in zone 1, which would be the region in northern Ontario, if it's the new asphalt binder, then you have to choose the performance grade of 52 minus 34. If it's reclaimed, we need to further downgrade the minimum temperature. That will be performance grade of 52 minus 40. You can find out the performance grade in zone 2 and zone 3. So that's the performance grade for the asphalt binder. And we also have more information we need to cover. We in the previous lectures, the design actually in the descriptions about the how to make superfill mix design, we also indicates that the performance grade is related to the traffic conditions. So in Ontario, we also do some corrections for the performance grade with respect to the traffic conditions. If it's in the urban freeways, if the pavement is conducted for urban freeways, then we have to increase the performance grade for 2 intervals from the standard level. And if it's in the rural freeway or the urban collectors, then we just need to increase one interval from the standard performance grade. Also, there will be some optional additional grade increase depending on this one. It's depending on the percentage of the heavy truck or the bus traffic operating at the slow speed, or they have the frequent stops or starts, or they have some historical concerns with the instability routings. So if there are some additional conditions, like when in this region there will be a lot of vehicles, a lot of trucks and buses which are moving slowly, they experience a lot of stop and go behaviors, and also the designer have some concerns about the stability of the routings or the pavement with respect to the routings. Then you need to do some additional increase about the performance grade. But this does not apply to the urban freeways. And for the rural arterial road or the urban collectors, we will consider increase by 1 grade if the percentage of the truck traffic is greater than 20, and also it has some additional grade increase depending whether there's a lot of heavy truck or the buses experience slow speed or stop and go behaviors. And for the rural collectors or the rural local road, the urban or suburban collectors, we don't need to do any change from the standard performance grades, but we may need to do 1 to 2 grade increase depending on the percentage of the truck and the performance of their behaviors. So that's about the performance grade of the asphalt binder in Ontario. And we also have some more information about the aggregate structures from the gyratory compaction test. So depending on the different type of the traffic, we will specify the percentage of the theoretical maximum specific gravity, which would be GMM. We need to have the maximum GMM at the initial gyration, the design gyration, and the maximum gyration. And also we have some specific voids in mineral aggregates VMA. So those would be the minimum values. And this minimum values is actually related to the nominal maximum aggregate size depending on the size of the NMAS, we will try to specify different minimum values of the VMA. For example, for the nominal maximum size of 37.5, the minimum VMA should be 11. So we have to make sure that the sample will have some value of VMA higher than 11%. Also, we have some requirements about the VFA for the traffic category A. It's between 70 to 80. For B, it's 60 to 78. For the other categories, that will be 65 to 75. For the dust proportion, it's as a constant. They all should be between 0.6 and 1.2. So this would be the material, the selections of the material, and we also have the number of the gyrations applied for the gyratory compaction test. This is also related to the traffic categories. For A, they have the initial value of 6 and then design value of 50 and maximum value of 75. And if we increase the volumes, you will see the increase in the initial values from 6, 7, 8 to 9. And for the design values also increase a lot from 50 to 75, 100, and 125. And of course, you're going to increase the maximum number of the gyrations. So this would be the requirement for the super pale mix design. And also we have to follow the standard moisture sensitivity analysis to measure the tensile strength ratio to make sure that the sample satisfies the minimum value of 80%. So that would be the requirement for the actually super pale mix design in Ontario. And we will follow the same protocol, but we have different requirements with respect to the performance grade of the super pale mix, the asphalt binders, and also the aggregates. So with that, I think I have finished all the contents about the asphalt technologies. Do you have any questions? Okay, if you don't have any questions, I would close this one and start reviewing the midterm exam. And feel free to interrupt me if you have any questions about the midterm.
I have one question, doctor, please.
Yes.
So are we going to go through the design steps? Would it be like a question in a midterm or something?
Yes, you have to go through all these steps. You don't need. Well, I'll give you more details about the questions in the exam. Give you some hint about how to answer those questions. Well, I can go back to your questions later, or if it's still not answered.
Okay.
Yes.
Thank you.
Okay. So for the midterm, okay. So the midterm, first for the time of the midterm, that will be 2:30 to 4:30 p.m. That's next Wednesday. I'm just trying to double check whether next Wednesday is November 3rd. Okay, next Wednesday, November 3rd. This is our tutorial time. And this exam is an open book, open note, so you can bring all the materials that are uploaded on Avenue to Learn, and also some reading materials that you collect from the other areas, other resources. They'll all be fine. The exam sheet will be distributed on Avenue. So at 2:30 p.m. on Wednesday, the exam sheet will be available for you to review. So you can download that one, or you can just open your computer, and then you're gonna work on either you can work on your computer electrically, or you can write down your answer in some separate sheets, and after that you're gonna scan it and upload your answer. Your answer should be uploaded to the Dropbox on Avenue in the folder of the midterm. I will create a folder there, and the deadline will be set as 4:30. And please make sure that you will save in sufficient time to upload your answer, say around 10 minutes. depending on how familiar you are about the scanning and also uploading process. And there will be some minor penalties for you if you complete everything late. And also try to save all your answers in one file. And if you write by your hand, clearly mark the page numbers so that we're gonna get the wrong orders about your questions, your answers. And also we allow you to upload multiple versions, but we will only take the latest version, which we will assume that latest version will be your final answer. And during the exam, I will open a meeting under the exam channel. I will create an exam channel in our Teams. And if there's any errors you find, or if there's any problems you want to ask, you can go to the that meeting. And I will encourage everyone to open that meeting during the exam in case if there's any things I want to update during the exam. Of course, I will try to mute myself, and everyone else should also mute yourself so that the it will not interrupt the other students. For the topics, we will include all the topics covered from the start of this class to the lecture today. So we will have the pavement type and distress. Those would be the fundamental definitions of the pavement. We have the soil properties and improvement about what kind of property we should use to understand the features of the soil and how we're going to improve the properties of the soils. And also we need to understand what's the impact of the moisture contents, the moisture contents to the properties of the soil. And the next thing is the subgrade structures. We need to know how we can design the subgrade by how we're going to select the appropriate materials for the subgrade. And the drainage design is another important topic. Of course, we will also consider the asphalt technologies. So for the pavement types, we will consider three types of the pavement: the flexible pavement, the rigid pavement, and the interlocking concrete pavement. The flexible pavement we will focus on the layered system. You need to know the surface layer, the base layer, sub-base layer, and the subgrade layer. And you also need to know the stress distributions over different layers, and also the conventional, the different type of the flexible pavement, the conventional pavement, full depth pavement, and the perpetual pavement. And for the rigid pavement, you have to know what type of the rigid pavement you can use. We have learned the stress distributions for the rigid pavement. And for the interlocking concrete pavement, you just need to know what this one is, how it's different from the previous two. For the stress, this will be related to the tutorial one. So in the tutorial one, we introduce different type of the stresses for the flexible pavement and the rigid pavement. You need to know how to identify these stresses, and also we have to understand what's the cause of this kind of the distresses, whether it's from the traffic loadings, whether it's from the weather conditions, or whether it's from the moisture contents, and so on. For the soil properties, we have introduced different methods for the soil classification. The ASHTO method and the USCS method should all be, you should know both of them, and also understand the grain size distribution. And for the properties of the soil for the pavement, you need to at least know three variables: the modulus of the subgrade reaction, modulus of the resilience, and the CBR. So know their definitions, know the way for us to measure those properties through the in the lab. This is also related to your lab experiment. And for the modulus of the resilience, we have the MR test. You have to know the procedures to conduct the MR test, the way for you to process the data, how to process the data collected from the experiment, and the way for you to conduct the regressions to get the to find out the relationship between the resilient modulus with respect to the bulk stress, the cyclist stress. For the CBR test, you also need to know how to do the CBR test. The way for you to conduct the analysis about the data collected in the CBR test, and you also need to understand how to work on the corrections for the data collected in the test. So that's for the two major properties, resilient modulus and the CBR. And for the soil improvement, this one I put this there, but it's not included in the midterm. I still have some connections to the topics in the soil property and some connections to the topics about the subgrade structure. But we do not have any questions directly related in this part. So for the soil improvement, we have the we need to understand the effect of the compaction, the effect of the moisture, the stabilization methods, geosynthetics admixture with bituminous lime and chemicals. You just need to have some brief ideas about those impact and the stabilization methods. And for the subgrade structures, this is another important topic we covered in this class. We first need to understand the effect of the water or the moisture contents to the subgrade materials, their impact to the resilient modulus, to the stiffness, and also how we're going to define the expansive soil. For the first heave effect, you need to know the cause of the first heave, the conditions for us to observe the first heave, the capillary rates, how we're going to estimate their rate, and how we're going to affect the or how we're going to induce the first heave. And also you have to understand what's the properties of the first susceptible soils, how it's going to affect the properties of or the functions of the subgrade structure. And the next thing for the subgrade structure is the effect of the moisture and the compaction levels. You need to understand how to estimate the moisture contents and what's the way for us to what's the standard procedure for us to conduct the compaction, and what's the effect of the compaction to the subgrade structure, and the different methods to conduct the compaction. In addition, there's a very typical discharge for the rigid pavement, which is called mud pumping. It's better for you to understand the mechanism of the mud pumping effect. And there will be another two concepts, the unbonded granular aggregates and the bond-based materials. For these two parts, just need to understand what's the concept, how they are defined. And the next topic is the drainage design, which will show you how to design the drainage layers and how you're gonna calculate the inflows to the drainage layer. So for the drainage materials, we introduced different aggregates, and we have showed the effect of the fine particles, the effect of the grain size, and also the filtering design. What's the retention criterions, what's the permeability criterions. And for the geotextiles, we also have some filtering criterions, including the retention and the permeability criterions. How we're going to select those materials correctly based on these criterions. And also we have some pipes. There will be some filter criterions for the pipes. And for the another important part about the drainage design is the procedure for the design. So that will include the calculation of the inflows. You have to know how to calculate the surface infiltration, the groundwater seepage, the meltwater from the ice lane, and also the design in how to calculate the overall design inflow. And for the drainage layer, there will be steady and unsteady state capacity. You need to know how to calculate these two capacities. And also there will be in collector pipes. We have some formulas to tell you how to choose the appropriate pipes with the given inflow rate. So that's the drainage design. And for the asphalt technology, we will only focus on the super pale mix design. We're gonna the Marshalls and VM mix design will not be covered in the midterm. So for the super mix design, you need to think about the material selection, what's the performance grade, what's the aggregate requirement, and for the design aggregate structure, we will majorly focus on the SGC super pale gelatin compaction test, how the test is conducted, and what's the how we're going to analyze the data from the test. And for the design binder content, we need to know some volumetric computations. This one's related to the tutorial 3, and also some the volumetric computation is related to the criterions for to select the asphalt binder contents. And also we have the moisture sensitivity analysis, the which will refer to the H2 test 283 procedures. You need to know how to conduct the sensitivity analysis and what's the criterion we have to use. Of course, you also need to understand the super pale mix design in Ontario, which was just introduced in this class. Okay, and so that's the topics will be covered. And for the questions in the midterm exam, there will be 2 parts. The first part will be 10 small questions, which will be the fundamental knowledge. Will give you some will ask you some questions about the features, the properties of the soils, the procedures of the experiments, and so on. For this kind of questions, some of you might think that you need to write a lot of text for that one, but it's not necessary. Just write down some keywords with respect to the questions, and our grading will actually based on those keywords. And as long as you have included all those keywords, you will get the full marks. And we also have two calculation questions. Let me double check whether it's 2 or 3. Yes, we have 2 calculation questions, and this was related to the calculation questions is very similar to the homework assignments. You will find out some similar questions in your homework. So I will encourage you to go back to check the solutions of the homework, well, I will post the solutions of homework too after the lecture today. So with that, you will have some ideas about you can solve them very quickly during the exam. Also, for the time for the total number of the marks, the total marks will be 60. There will be 40 points for the first part, the questions, fundamental knowledge questions, and we have 20 points for the 2 computational questions. Each one will have 10 points. So any questions about it for now? If you have any questions, you can raise your hand, or just you can just or you can leave your message in the meeting chat. Okay, I'm not quite sure whether the one that I include has just fixed the questions that we have previously. Just feel free to leave your questions or concerns about the exam. Okay. if we don't have any additional questions, I guess we still have plenty of the time for the quiz. I will just open the quiz for you to work with. It will be on Avenue to Learn. Just a moment, let me try to make it visible for you. So the it should be able for you to see for now. Yes, you can work on these two questions in the on Avenue to Learn until 5:20, and just let me know if you have any questions about it. Okay, with that, I will stop recording this lecture and let you work on the questions on Avenue to Learn.